Hi guys, welcome to this video, and over here this is one of the very much requested question on vectors, and this is from chapter 12 mixed exercise question number 10. And basically it's a fairly lengthy question, so let's dive right in. Okay, so it says over here that we have been given a tetrahedron OABC, and these are the position vectors of A, B and C. Furthermore, we are given that these are the midpoints of these line segments, and we need to prove that the line segment PQ, RS, and TU meet at a point and bisect each other. So we can clearly see that they are meeting at one point, and I'm just going to call it with a letter M. So I'm going to split this up into three sections where I'll be dealing with PQ and RS together, and then I'll be working on TU as well. So first of all, I'm going to write down PM as some scale factor, let's say K, of PQ. Similarly, I can write down RM as another scale factor such as lambda times by RS. Okay, and finally TM can be written as, let's say, mu times TU. So by writing down these scale factors, my aim is to find them out, and we are hoping that the numbers, or well, the scale factors are all the same, and they will be, we are trying to prove that they're equal to half. Okay, so let's start with first PM. Okay, so PM can be written as from P to O plus O to R plus R to M. Now we know that PO is minus half of C, okay, because OC is C, and OR is just half of A, okay, and RM is some scale factor lambda of RS. Okay, so that's our PM. Okay, and in fact PM is equal to K times PQ. Now I can see over here that there are two unknowns. We don't know what PQ is or RS is. So let's go ahead and find that out one by one. So let's start with PQ. Okay, so PQ, just gonna do it in a different color. Okay, so PQ can be written as P to O plus O to A plus A to Q. And that is, again, minus half of C plus A plus, well, half of AB, yet another unknown. Okay, so if I want to find out AB, I can just write that down on the side. So AB is simply from A to O and O to B. Okay, and both of them are given to me. A to O is minus A, and O to B is just B. So I have my AB. So that will be equal to minus half C plus A plus half of minus A plus B. Okay, so if I expand and tidy this out, I would end up basically with half of A plus half of B minus half of C. Now I can see a common factor of half. I'll leave it out there just for now, okay, because I would have to soon compare the scale factors, so I'll leave it there. So PQ is done. Now let's work out the vector RS. So vector RS is going to be, let's put this out here. Alright, so RS can be written as R to O plus O to C plus C to S. And R to O is minus half of A plus C plus half of, well, CB. Okay, and again, we don't know what CB is, so we can work that out quite quickly. So CB can be written as C to A plus A to B. And that is just, well, minus C plus A, okay, minus A plus B, which we have already found out. So in other words, it will give you minus C plus B as CB. Okay, so let's put that down as well. So that will be half of A plus C plus half of CB, which is B minus C. And again, I can expand and tidy this up. I'm skipping a few steps just to speed things up, but feel free to go through those steps if you're unsure, and you will end up getting minus half A plus half of C plus half of B in the end. So that's your RS done. Okay, now if we put these together, the red section and the blue section with our P, this equation right here, this one right here, okay, we will be able to compare the coefficients and work out the values of K and lambda. Okay, so let's go ahead and do that. So I am going to just zoom out slightly. Alright, let's put that here. Cool. So with that, let's write down. We have K times by PQ. Okay, so K is, I'm just going to go back to black. Okay. So K times by PQ, which is half of A plus half of B minus half of C, which is equal to minus half of C plus half of A plus lambda of minus half A plus half of C plus half of B. Okay, so that is my one full equation with K and lambda unknown. So I'm just going to expand this and put the coefficients of A and B together. So half of, let's say, Ka plus half of Kb minus half of Kc. And here I'm going to have, in terms of lambda, A lambda plus half of C lambda plus half of B lambda. Now, if I start by comparing the coefficients of, let's say, A, okay, I have got half of K, and I've got half over here and a minus half of, well, lambda. Okay, so those are my A's. So by comparing the coefficient of vector A, I'll get half of K equals half minus half of lambda. So from here, I can quite simply simplify by timesing everything by a 2, and I would end up getting K equals 1 minus lambda, or K plus lambda equals 1. Okay, so I've got that there sorted. Now, I need another equation because I need to figure out what are the values of K and lambda. So if I now pick out, let's say, my coefficients of B, okay, so I've got half of K, B over here, and I've got a half of B lambda here. So if I compare those two, so comparing coefficients of B, I would end up getting half of K equals half of half of lambda, which means that K is equal to lambda. And if K and lambda are the same, if I put this into there, okay, and solve for either one of them, I would end up getting, for example, 2K equals 1, okay, where lambda is equal to K, and K is equal to half, and so is the lambda. So there I've got my two scale factors as half and equal, which proves that, well, PQ, first of all, so I can just write that down, result at the top. Okay, so I've got PM is therefore half of PQ, and RM is also half of RS. So I've got those two results. Now, I just need to work out my final bit, which is TM. Okay, so let's get rid of some of the work, or I'll just leave it there and see if I need to get rid of it. Okay, let's just do this in a different... Okay, right, let's stick to black. Right, so we have TM. Now, TM, as we've said, is equal to mu times TU. Okay, so I'm going to work out what TM is and what TU is, and then compare the ratios and see what I get for mu. Okay, so TM can be written as T to O plus O to R and R to N. Okay, so that is going to give me minus half of B plus half of A plus, well, half of RS, okay, and I know what RS is. It is right here with me, okay, so I'm going to use that. So half of minus half A plus half of C plus half of B. Okay, now when I expand the brackets and simplify this, I'm going to end up getting a quarter of A minus B plus C. Okay, so feel free to pause the video over here and see whether you do get the same result as me. Okay, and otherwise this is basically the end bit, okay, of TM. The final result of TU similarly can be found as well. So TU is simply T to O plus O to A plus A to U. Okay, so TO is again minus half B plus A plus half of AC. Okay, AU, right, because U is the midpoint, is half of AC. Now AC is simply going to be from A to O and then O to C. Okay, so minus A plus C. Okay, so I'm just going to put that down over here. So minus A plus C. Alright, so again, when I simplify this result, I am going to get a half in common with A minus B plus C. So there you have it, actually, almost there. So let's now get rid of a bit of this work at the bottom. So let's say, okay. So what we've got over here is the ratios now. Okay, so I've got TM, to TU. And because you've got the same vector form, you've got A minus B plus C here and A minus B plus C here as well, we can safely say that the ratios are therefore comparable. So a quarter to half, okay? Or that basically turns into a half to 1. Okay, so that means that TM is, well, half of TU. And there you have it. You have all three results. And because the midpoint, or rather, midpoint, we can call it a midpoint, is M, okay? They all have M in common in the result. Therefore, they do bisect at a point. And here you have it. So this was a brilliant question. I hope you found this useful. Let me know in the comments below if you do have any questions. Thanks ever so much.